confidence interval for one sample mean, called a t-interval. As always, you have the same steps. State your random variable and parameter, state and check your conditions, do your calculations, do your statistical interpretation, and your real-world interpretation. So in this problem, you're going to find your confidence interval for the following problem. A major car manufacturer wants to test a new engine to determine whether it meets air pollution standards. 10 engines are manufactured for testing purposes, and the emission levels of each are determined. The data in parts per million are in the dataset engines. So let's go ahead and run the setup. There's our engines. There are 10 observations. We can do a glimpse of it, give you an idea of what they look like. Okay. So again, first step is to state the random variable and the parameter. So our random variable is the emission level of a new engine. The parameter is the mean emission level of a new engine. Now let's state and check the conditions. So first state is that you have a random sample of 10 emission levels of a new engine are taken. I'm going to check this, and the problem is that I don't think this is true, because it says right here that they made them for this purpose. They manufactured them for testing purposes. Reality is they probably need to do it that way, but you don't know for sure. So this may not be true. But we're going to go with it because most likely they probably they probably manufactured them for this purpose. So it probably is okay. Maybe say something like this may work in this case. We need to state that the population of all emission levels of the new engine is normal. So let's go check that. Remember, for this check, you're going to go ahead and do a normal quantile plot and a density plot. We'll do a GF underscore density. Our explanatory variable is, I believe, emissions, but let's just make sure. Emission. And data is equal to engines. Because that's where the data set is. And then we don't know what the mean is. We don't need the mean, but we do need the conf.level. And it wants us to do this at a 95%. So we'll do a 95%. Again, this one is 95 is kind of the default, but it's always good to put it in there. Just make sure you don't forget to do that when it's not the default. Run it. Oh, wait, sorry. We don't need the conf.level on this one because this is a density plot. I do need a title though. Titles are always good. So I might put down the emission level of the new engine. And I might want to have a better XLab of saying things like emission level. So let's run this again. This doesn't look really normal. I mean, it looks a little belted. It looks a little skewed slightly. So let's go ahead and do the quantile plot. See what that one also looks like. And everything else is the same. So we're just going to go copy that. Paste it in there. I don't think I need the XLab. It puts in its own that I kind of like. So I'll leave that one out on this case. And we'll run it. And again, this looks a little not real linear. does look linear as we get a little bit farther on, but lower values, it doesn't look really linear, but I think we only have 10 values. I think we're probably okay. So we could say the density plot is somewhat bell-shaped. And the normal quantile plot is somewhat linear. All right. So now we get to our calculation stage. And we're going to use a t-dot test. We're going to tell it that our explanatory variable is emission. Our data set is the engines. And this is we're going to put in the conf.level is equal to 0.95. Again, it will assume it is, but we're going to put that in just to make sure we don't forget it when it's not. All right, and here is our confidence level right here. So our statistical interpretation is that I am 95% confident that the interval 15 to 19.3, and let's look at what the units are on this. So let's just see. I can't remember the units, so let's go up and look at this. Oh, we do, oh, parts per million. So ppm is contains the true emission level of the new engine. And then we can do the real world interpretation. And what you would say here is, again, what we were trying to find was the mean emission level of the new engine. So we can now say that the mean emission level of the new engine is between 15 to 19.3 parts per million. And if we knew what the new emission standards, new pollution standards were, we could see if this is within those. Because if the new pollution standards are in this interval, then we would say it doesn't meet it because they shouldn't be there. If it's outside that interval, we could then say how it meets or not meets. And there we go.